based on the methods used, they are again classified as rational design, that is rational design. Second one is empirical design, that is EMPI, empirical design. And third one is the industrial design. Okay, so based on the methods they use for designing, it is classified, the design is classified into rational design, empirical design, and industrial design. So what do we mean by rational design? Whenever mathematics is used for designing a component, that is to design or determine the size of the component, then we say such design as rational design. Example, boilers, okay. Then you got several other examples like bridges, cranes, etc. Okay. Okay, so you have got various examples such as bridges, right, boilers, cranes, etc., which come under rational design. As I said, we call a design a rational design wherever mathematics is involved. Okay, mathematical equations are involved in determining the size of the component. Next is empirical design. This empirical design, okay, depends upon the empirical formulae that are obtained by practice and past experience. Okay, so such designs are called empirical designs. Okay, are you there? Are you there with me? Okay, third one is the industrial design. Okay, so essentially the industrial design is the design which have manufacturing aspects. That is, they will have manufacturing aspects in the design. Okay, such design is called industrial design. Essentially, such designs are used in producing the components. So the examples can be the jigs and fixtures. Okay, jigs and fixtures are extensively used in industries to mass produce the components. Say for example, if you have to drill, okay, some say several holes, okay, with different pitch and different diameters, and they need not be in one pitch circle, so they can have different pitch circles. When you have to mass produce such components, you cannot locate every hole, okay, then start drilling. It takes one component to be, even after 8 hours also, we cannot produce one component, and also the accuracy will be a problem. So to produce such components, they do what are called as drill jigs. Okay, drill jigs. They produce a master, okay, with the greatest accuracy, then place that on the component where it has to have so many drills. So together they will drill through those jigs, okay, and thereby you can produce en masse the components with greatest accuracy. So they are called drill jigs. Fixtures essentially are used for mass producing of components accurately, that is to hold a component, to do machining and all those things. Say for example, if you want to hob a mill gear, okay, so they use hobbing fixtures, milling fixtures, and so on. That is to produce components, okay, en mass. They use these fixtures called milling fixtures or hobbing fixtures, okay, and so on. They are essentially used for holding the component in position during machining operation. So such a design is called the industrial design. So what are the three designs? Rational design, empirical design, industrial design. Rational design, where mathematics is involved in determining the size of the components. Examples, boilers, bridges, cranes, etc. Empirical design, essentially that design which is based on empirical formulae which are produced by practice and past experience. Industrial design, wherein there is going to be manufacturing aspects. Okay, and examples are jigs and fixtures, that is drill jigs and milling fixtures, you can say. So fixtures are essentially used for holding the component in position during machining operation. Okay, so this is about another classification of machine design. Please note down these three. Please note down these three. Classification of machine design. Please note down. Noted? Noted down?
Yes.
Yeah, note down. Rational design. Rational design. Whenever mathematics is involved, please note down. Whenever mathematics is involved, whenever mathematics is involved, to determine the size of the components, whenever mathematics is involved to determine the size of the components, the design is said to be rational design. The design is said to be rational design. Example, bridges, boilers, cranes, etc. Finished, huh? Finished noting?
Yes, sir. Yes, sir.
Next, empirical design. Empirical design. This design depends upon empirical formulae based on the practice and past experience. Full stop. It is the result of using data. It is the result of using data derived from machines and designs in actual use and such data is tabulated in various handbooks. and such data is tabulated, in various handbooks. Next one, industrial design. Industrial design. This design depends upon the production aspects of to manufacture any machine component, in the industry. Examples. What are the examples? Yeah? Yeah, please louder a bit.
Jigs and fixtures.
Yeah, exactly. Jigs and fixtures. Please note down. Others, Desai, what is that I have written now on the board? Others?
So, Shigley's design process.
Yeah, okay. All right, now we are going to learn about the design process. That is, what are the steps involved in the process of designing a component? Essentially, it is given by Joseph Edward Shigley, so therefore it is called Shigley's design process. Right? Basically, it has got 6 steps. First one is the recognition of need. This is the first step in the process, that is recognition of need, that there exists a problem. Next is the definition of the problem. Definition of problem. That is the second step in the design process. Definition of problem. Third one is the synthesis. Third one is the synthesis. Next is analysis and optimization. Analysis and optimization is the next step. Next is, after analysis and design, it is going to be the evaluation step. And last step is going to be the presentation of the design. Okay? These are the 6 steps in the design process, universally adopted. So if there is any variation in analysis, the feedback is given to synthesis level, and also from evaluation, it will go to synthesis. Is it okay? Is whatever that I have written is clear in your screens? Is that clear?
Yes, sir. Yes, sir.
So the Shigley's design process involves 6 steps. First one is a recognition of need. Recognition of need in the sense that someone should recognize that there exists a problem that is to be solved or action need to be taken. So that is the recognition of need. Okay. Next comes definition of problem. So whatever the problem that is posed or the problem or a need is there, so we have to define the problem clearly. That is, from unstructured, we try to move towards structured problem, right? So that is what is happening in definition of a problem. Then comes synthesis. What do you mean by synthesis? What do you mean by synthesis? Synthesis is to put together, correct? So that means we are going to assemble various components together to produce a machine, okay, after recognizing and defining the problem. That is what is called as synthesis. What is analysis? This we have seen in the previous class. Synthesis is to put together. Analysis is what? What we have understood as analysis? Yeah, someone please go back in your notebook and check what is analysis. Yeah, someone refer back to the notebook.
Sir, to decompose, to tear apart, and to resolve.
Yeah, okay, that is to take apart various components in the assembly and find out the forces. And optimization is, by name itself, it says we are going to optimize the size of the components, material will be optimized, and so on. So after analysis and optimization, if there is any deviation or correction required, it will go back to synthesis stage, and then it will come back to analysis, okay, whether the components are really working or the optimization is complete. Once analysis, that is to evaluate forces and determine the sizes, it will go to evaluation stage. Evaluation is essentially like testing a component. Okay, that's how you evaluate a machine that you have developed. Okay, so in the evaluation process for doing the testing, essentially you need a prototype of the machine that we have designed for evaluation. So if there is any deviation in the testing process, then again the feedback will be given to synthesis. Again further correction is going to be made, analyzed, and then again retested. Okay, our retesting of machine would occur in evaluation stage. Once evaluation is complete and it is satisfactory, then it will go for presentation. Presentation essentially here, it is the demonstration of design by means of drawings, okay, and material specifications and assembly process, etc. So all those things comes under presentation. This is the design process as given by Shigley. Are you with me? Say suppose if you want to have, if you are given a problem that you need to rotate a shaft. So that is the basic, you want something to be rotated. Okay, that is the recognition of need. Definition of problem, so the shaft has to rotate at certain RPM. So you have to build a machine. I am just taking an example. So you have got a shaft. This shaft needs to be rotated. Okay. So for the shaft to rotate, what we need? We need some prime mover, maybe in the form of a motor. Okay. So a motor will have a small shaft along with that. So these two have to be coupled. Okay. Next, what should be the speed of the shaft that we are going to design? And then whatever, say if I take the shaft to be run at 2000 RPM, and then when it runs at 2000 RPM, the motor should be fixed properly, okay? And the shaft should not twist beyond the permissible limits. So again, determine the size of the component. Say suppose if this component is also subjected to a transverse load, okay? So it should not bend beyond say 0.003 millimeter. It should not deflect because of the applied load. Because of torsion that it is subjected to, shear stress should not exceed say 30 megapascal and so on. With those constraints, we are going to design the component, that is the shaft, and then do the evaluation, find out if there is any deviation, and then present it in the form of drawings, material specifications, and assembly, etc. Is it okay? This is essentially the Shigley's design process. So all of you please note down these steps. Many times this is asked in the examination. So please note down clearly. Okay. And you can remember this by taking in the first letter RDS, A, E, and P. Okay, that is recognition of need, definition of problem, synthesis, analysis and optimization, evaluation, and presentation. So that way you can remember easily the steps involved in the design process. Is that okay? As provided by Shigley. Please note down. All of you should note down because next examination is not going to be online and you will not be given free entry to next semester. Okay? Because already exams are conducted successfully this time. So you will have exams definitely. So please keep writing. Are you able to see the things clearly in your screens?
Yes, sir.
Fine.
Excuse me, sir.
Yeah.
So this is regarding the classification of design.
This is regarding?
Classification of design, sir.
No.
Sir,
This
can
is a
we-
design process.
No, sir. I had a doubt.
Classification is over.
I had a doubt, sir. Doubt.
Yeah, tell me.
So can we say the empirical design comes under development design?
No. Empirical design. See, you have various data handbooks, like gear data handbook you have got, okay, and we have machine design data handbook. So the formulae are given in the data handbook to calculate. How they have arrived is essentially by continuous evaluation and experimentation and past experience. They would have done lakhs of components and they would have arrived at this will behave like this if I take this much. So they will have that empirical relation developed over a period of time. Okay. So if the design is based on the equations that we take from data handbooks, such design is the empirical design. Okay. Whereas in development design, it is essentially you have a product already. If you start your design with the existing product and produce a totally new component, then it is called development design. See, that is based on method. The method, this is based on the methods that are used. For example, rational, empirical, and industrial design, they are based on the methods adopted. Okay? That is essentially based on method. But whereas your adaptive development design and new design, they are based on the type of adaptation that we make for design. So that is the difference between adaptive development and new design and rational, empirical, and industrial design.
Okay, sir. Thank you, sir.
Yeah. See, in empirical formulae, no mathematics is involved. They have derived with some experience. Whereas in rational design, they have used mathematical equations to arrive at the component. So that is essentially method that is used in designing the component. Okay. Got the clarity?
Yes, sir.
Yeah. Others, have you noted down this? Shall I remove? Anybody still writing?
1 minute, sir.
Yeah. If you have finished, say yes.
Yes, sir.
Next is use of standards in design. Okay, use of standards. It can be in the design, manufacturing, testing, anything. So what do you mean by standards? Standards essentially is the obligatory norm to which, okay, the characteristics of a product should conform to. That is essentially you develop a machine. So the simplest I'm going to take is maybe a bike you are going to develop, or you are going to develop a new car. Okay, so here each such bike or a car will involve some thousands of parts. Okay, so each part should conform to certain standards. Okay, international standards. Okay, that are defined. If the component or product that you are designing is not conforming to the standards given, then your product will not be accepted in the market and it will not be allowed to run in the market. So that is what is standards is all about. So we have standards for drawings, we have standards for bolts and nuts, we have got standards for plating. Say if you look at this bolt and nut assembly, okay, so this thread will have a standard, so you cannot have the pitch as you wish. Okay, for this diameter, that they are the standard pitch. Say this is a 10 mm diameter bolt. Okay, the pitch of 10 mm diameter bolt can be 1 mm. If you cannot keep it as 1.15 mm, you cannot take it as 1.25 mm as the pitch. So for M10 bolt, 1 mm is the pitch. That is the standard. And if you see this bolt and nut assembly, if you hear, it is chrome plated. Okay, so plating thickness is also there is a standard. Okay, and you cannot use zinc plating because it is environmental unfriendly. So you can go for chromium plating or whatever the plating. Again, there you have got various standards for plating, and you have drawing. If you take up, you have first angle projection and third angle projection. You cannot have drawing in second angle and fourth angle projection. Like that, every component, whether it's a pressure vessel, gear or a clutch or a brake or car as a whole, each one of them have got to conform to certain standards. Okay, so the standardization is essentially the obligatory norm to which the characteristic of a product should conform to. So that is what is called as standardization. Okay, as I said, we have standards for materials, standards for chemical composition. Say for example, I manufacture C40 steel. Somebody manufactures same C40 steel in US or Japan or somewhere. Okay, so the C40 has got a composition. That means it can have this much phosphorus, this much carbon, this much steel composition is this much. Or if you take aluminium, okay, aluminium metal matrix composite, so it will have some composition fixed. The same C40 steel wherever you produce should conform to the composition that is specified in ASTM handbook, data handbook. Is that okay? Like that, you have standards for materials, standards for drawings, standard for bolts, boilers, automobiles, and engineering drawing, and so on. So that is essentially standardization. So why do we need standardization? Is for the interchanging of parts. Say for example, you import a car from somewhere, and a small bolt will go, small nut will go. You should be able to replace such standardized products as bolts and nuts in the market that you are in. Okay, that is essentially, that's why the standards has come into picture. Okay, so it is essentially set of specifications that a part or machine should conform to. That's it. Okay, and we have got various international organizations for standards. So few of them I'll try to name here. You have got AGMA, that is American Gear Manufacturers Association. So you have got they'll produce a gear data handbook. So all the gears that you produce should conform to the standards of American Gear Manufacturers Association. And similarly, you have got ASTM standards, American Standards for Testing on Materials. Okay, that is ASTM standard. Say for example, in impact test. Okay, what are the two types of impact tests that we do? Yeah, eyes are done. Which is the other one?
Sure.
Sharp test. Okay, and we make V notch and U notch. Again, that V notch and U notch has got certain dimensions to conform. So that is essentially given by American Society for Testing and Materials. So whatever the testing that we do here, this testing dimension should conform to ASTM standards. So like that, you've got DIN standards, British standards, and there are certain companies like Toyota and Volvo. Okay, such companies, they have got their own standards. So if you are a supplier to Volvo or Toyota, you should conform to the standards that are provided by these companies. They don't follow any of the standards. Okay, they follow their own, they have developed their own standards and they follow their own standards, especially Volvo and Toyota. If you are a supplier of the component, so you need to conform to their standards. Okay, so there are such standards available. So this is about standardization and various standards that are practiced globally. Okay, and next we have got factors influencing the selection of suitable material. That is, factors influencing suitable material for a design. Okay, so what are the factors that influence the selection of suitable material for a design of machine element? Okay, for suitable material, you can say for machine design. Okay, what are the properties? Okay, what are the factors that will influence a design engineer to select such materials? This is what we need to understand here. Factors influencing suitable material selection for machine design. So first one in that is the strength and rigidity. You have various properties: ductility and the castability, machinability, forgeability, damping capacity. Next is resistance to fatigue. Next is damping capacity. Damping capacity. Next is machinability, or I would say resilience. Next is maybe weight. Okay, castability. Castability. Next is machinability, forging characteristics. Machinability, forging characteristics. And next one may be availability and cost. And these are the factors that will influence selection of material in machine design. Okay, first one is strength and rigidity. So that means if you are designing a gear, okay, it has to withstand static and dynamic loading. Okay, so therefore the gear teeth that we design, the material that we choose for designing a gear teeth should have sufficient strength, and it should be rigid enough to take up starting torques as well, which is more. So The strength and rigidity is one of the factors influencing selection of suitable material. Next is resistance to fatigue. What do you mean by resistance to fatigue? Say for example, your tire is subjected to repeated loading. In an IC engine, as long as your engine is running, the piston connecting rod is constantly subjected to loading, and also the valve and valve spring are subjected to continuous operations of lakhs of cycles. Okay, so the valve springs and valves are subjected to lakhs of cycles. Your gear is subjected to lakhs of cycles. Okay, your crankshaft is subjected to lakhs of cycles. That is essentially all the components are subjected to lakhs of cycles during their lifetime. The components that we use should withstand, okay, for so many lakhs of cycles. So that means the material that we choose should have good resistance for fatigue or repeated loading. That's what resistance to fatigue means. Are you with me? Are you with me? Are you there?
Yes.
Yes, sir.
Yes, sir.
Next is damping capacity. What do you mean by damping capacity? Anybody, any idea? Have you used bikes? Used bikes, no? Bikes and cars?
Yes, sir.
So on your potholes and humps, which component will take up the load?
String.
Yeah.
Yeah.
The
Suspension.
damper suspensions.
Yeah. Suspension system, correct? So it is essentially spring and damping system. So what does it do? It essentially absorbs vibrations. That means damping is, the definition of damping is to resist vibration. That is what is called as damping. So the damping capacity of the material that we choose for design, it should have good damping capacity. That means it should absorb the vibrations that are generated during operation of the component. So that is what is called as damping capacity. Next is resilience. So resilience we have seen in our previous class, it is the energy absorbed by the member, okay, because of applied load. Next comes weight. Okay, so the weight to strength ratio. Okay, so or the other way is, yeah, high weight to strength ratio. If I call it as high weight to strength ratio, for flywheel design, you need higher weight to strength ratio. For otherwise, for aeroplane applications, you need low weight to strength ratio. That means it should be stronger, but at the same time, its weight should be less. Okay, so weight is another factor that will influence our selection of suitable material in machine design. If you are designing the aerospace component, you should select material such a way that its strength should be more and at the same time its weight should be less. Are you there with me? Are you there? Next is castability. That means if you are using casting process for the component that you have designed, the material should have castability characteristics. That means it should be the material should be castable. That means you should be able to cast that material. That is what is called as castability. Next comes machinability. So what do you mean by machinability? Any idea? Machinability?
Creating parts using milling or.
Yeah, good. That's okay. So that is essentially the material that we choose should be machinable. If you choose titanium as material, okay, it is so hard that you cannot use conventional machines to machine it, and it takes long time for machining the titanium material. Okay, so therefore the material that we choose in our design process should be machinable. That means it should be easy to do operations and remove material. Next comes forging characteristics. That means if you are using a material, okay, it should get into plastic region faster. So that means it should be able to get forged. Okay, so that is forging characteristics. Last one is availability and cost. The material that we choose for our design should be available. You design a beautiful design, but finally the material is not available, means your entire design is useless. Correct? Are you there with me?
Yes, sir.
Yes, sir.
Therefore, the material that we use during our design should be available, and also it should be cost effective. Okay, if you design all the parts using titanium, it will be strong. Its tensile strength is too high. Everything is excellent, but the cost of titanium is too high, so you cannot use titanium for all the applications. Okay, so therefore, availability and cost also plays a major role in selection of suitable material in machine design. Are you with me? Are you with me? This is another very important question in your regular examinations. So just note down factors influencing suitable material for machine design. So note down strength and rigidity, resistance to fatigue, damping capacity, resilience, weight, castability, machinability, forging characteristics, availability, and cost. Please note down this much. And also you can add one more, resistance to wear and corrosion. Resistance to wear and corrosion. That means the materials that we choose should withstand the wear, and also it should resist the corrosion, because the component that you design should be useful even in coastal area where you have got more salt in the atmosphere and the components are subjected to more corrosion. So the components that you design and the material that you choose should work both in coastal environment and also non-coastal environment. That means it should have good resistance against corrosion. Is that okay? Are you there with me?
Yes, sir.
Yes.
Yeah.
Yes, sir.
Please note down these points. Please note down these points. Shigley's design process, standardization and user standards, and the factors influencing suitable material for machine design. So these are all some of the important theory questions for your examination. Okay. Finished, huh?
Yes, sir.
Anybody still to write? Okay, I will remove them. Okay, next is load and types of loads. What do you mean by load? What do you mean by load? What do you mean by load? Anybody?
Adding a force.
Application of stress.
Yeah?
Basic application of stress on a material.
No, stress is not application. Stress is induced. Load is applied. Okay? When you apply load, stress is induced. Correct or not the other way? I'll tell you. Load is any external force. Okay? Any external force that is acting, okay, on a body is called load. Any external force acting on a body is called a force. What are all the different types of forces? What are the different types of forces? Temperature can be a force, pressure can be a force, impact load can be a force, axial load, bending load, torsion, okay, point load, uniformly distributed load. These are all types of loads. These are all external forces acting on a body. Okay, stress is induced, load is applied. Okay, Tarun, got the clarity?
Yes, sir.
Okay. Yeah. Next is dead or steady load. Next is dead load or steady load is the next one. Dead or steady load. So where load is constant is the load wherein it does not change in magnitude and direction. Okay. So that is what is called as dead or steady load. So there is no change in magnitude and direction of load. So such load is called dead or steady load. That is essentially loads on beams, okay, and columns, girders, etc. They are all dead or steady load. Okay. Next comes variable load. So in variable load, there is going to be change in magnitude and direction dynamically, or when suddenly applied load. When load is suddenly applied or removed, then also it is called, okay, variable load. Okay, there is going to be change. Next comes impact load. Impact load is essentially the load that is applied at a high velocity. So that is impact load. Is it okay? So then we have got another classification called static loading and dynamic loading. Okay. In static loading, the load is applied gradually, and once it reaches maximum, it will stay as constant. Whereas in dynamic loads, the load keeps on changing dynamically over a period of time. Okay. So there's going to be variation in the amount of load on the component. So that is called as dynamic loading, wherein the load will be increased from 0 to its maximum, and after that it changes its magnitude and direction, or direction whatever, okay, in the very frequently. Such load is called the dynamic load. Okay, so these are all some basics of loads and types of loads. So basically, load is any external force that is acting on a body. So it can be classified as dead or steady load and variable load. In dead load, the load does not change. That is, its magnitude and direction remains same. Whereas in variable load, if the load is applied or removed suddenly, or there is a variation in the load, its magnitude and direction, then we call it as variable load. And then impact load, when it is applied at high velocity, we call it as impact load. Another classification is static and dynamic, wherein in static the load starts from 0, reaches the maximum, and it will stay there as constant. Whereas in dynamic load, Here also the load starts from 0, reaches its maximum, then again changes its magnitude and direction, and that process is constant. That is, it's going to be dynamically changing in magnitude and direction. So such loads are called dynamic loads. Got the clarity? Got the clarity now? Okay.
Yes, sir.
Okay, we'll take attendance now. All of you, please switch on your. Somebody has given chat. No need of giving ESN in chat. We have to stay there for the attendance. Please switch on your videos, please. Sai Sumant.
Present, sir.
Okay. Abhishek GL. Abhishek GL. Not there. Okay. Abhishek Narayan. Abhishek Narayan. Adarsh Desai.
Present, sir.
Switch on videos, man, for a second. Your data will be as it is, okay? Ajay Sunil,
Yes, sir.
please switch on the video. I am telling you, switch on the video and then say yes and then vote.
Yes, sir.
Akram Anwar. Akram Anwar. Akshay Jadhav.
Yes, sir.
Yeah. Mundiyar.
Present, sir.
Yeah. Nambiar.
Present, sir.
Nadella.
Yes, sir.
Beban Kalita.
Present, sir.
Chinmayi Prasad. Yeah. Chandan Swarup. Chandan Swarup. Charishma.
Present, sir.
Darshan. Darshan.
Present, sir.
Yeah. Ibat Kausar. Ibat Kausar. Govind Raj.
Present, sir.
Jayant Reddy. Jayant Reddy. Purushottam Reddy. Ritik Shah.
Sir, 003, present, sir.
Present, sir.
Where you have come now? Join now?
No, sir, I was there. I was there, sir.
Sure, show me the book, sir. Show me the book that you have noted down. Put the book in front of the camera. Not there.
Right here, sir.
Yeah, show me the book that you have written. No, I don't want front sheet there. Go inside. Go inside the book, man. Make it fast.
Yes, sir.
Have you written or not? That you tell me. Is it today's, sir?
Yesterday, sir.
What
Last
about today?
class.
Today
Today
what
also I
you
wrote,
have
sir.
written? Huh?
Today also I wrote, sir.
Where? Show me that, man. That's what I'm asking. Huh? Don't play
I'll show
around.
tomorrow, sir.
See, I'm telling you, don't play around. Bloody, if you are interested, you sit. Otherwise, bloody quit. Don't want. Okay? I need it just because you are offline, you cannot take things for granted. If you are interested, sit in the class and do what I instruct you to say. Okay? You have to learn. You are not learning for my sake, you are learning for your sake. You have to learn. Don't come on now and say, I am present. All those excuses are there. Internet not working, these are all we are hearing. There may be genuine issues also. But when I said I am giving you time to note down, you are not doing that.
I'll do it.
And have some responsibility. Go. Ritiksha?
Yes, sir.
All of you, please note down, okay? Whenever it is said to note down, please note down, okay? Otherwise, I'll keep going. It is